Today I'm going to demonstrate how to use the Grun Net tools for testing and debugging ANTLR for grammars compiled using C#. The primary purpose of these tools is to allow you to test directly with your .NET assemblies in the same way that you can currently test Java assemblies via the existing test rig. Grun Net primarily consists of two tools. The first tool is the Grun executable, which is a command line tool. This tool mirrors existing Java test rig functionality. The second tool is the Grun executable, which is a graphical testing application. Grun can be run as a standalone executable, or it can be run from the Grun command line tool. I'll cover each of these tools in depth. First, I'm going to be testing a grammar called mu, a dynamic object-oriented language. As you can see, I'm currently in a directory that contains my mu grammar assembly. First, I'll demonstrate the Grun command line tool. So, now that I've run it, you can see a list of the parameters and flags that the tool supports. You'll notice this tool supports all the same flags as the Java test rig except for the PS flag. I couldn't find a way to export the graph to PostScript, so unfortunately, that flag won't be supported. However, I do have an SVG flag for exporting the graph into a scalable vector graphic file. Should you still need the graph in PostScript format, there are a number of tools for converting scalable vector graphic files to PostScript. All other flags produce identical output to the ANTLR test rig. Let's go ahead and demonstrate the tokens flag. So I'll type Grun, mu is my grammar, code is my top level parser rule, and then we'll supply tokens. So you can see it's reading from standard input. Let's go ahead and copy a code snippet, paste it in, terminate the input, and now you can see a list of all the tokens. So again, this output is exactly what you would normally expect from the test rig. So this time, let's go ahead and run it again, but using the tree flag. Paste our input, terminate the lines, and now you can see the tokens again, but this time also with a Lisp style parse tree of the source. So now let's run it with the GUI flag. It's important to note that the flag does not simply display a parse graph, but instead runs the Grun tool. This tool includes a parse tree graph along with many other features. So let's go ahead and paste in our sample again. And now you can see the Grun tool. So as I mentioned before, the executable can be run as a standalone application. First, you'll notice a number of parts to the application. At the top, we have a standard menu. On the left, we have a feature-rich editor for entering the text to test with a parser. On the right, we have a set of tabbed windows. First, we have the graphical parse tree. Next, we have the tokens window that displays a list of all the tokens. And then we have the trace window, which currently we have tracing turned off, but I'll come back to that later. Now, at the bottom, we have a parser error message window. And lastly, below that, we have a status bar with various pieces of information. Now I'll go into each component more in depth, starting with the editor. The editor displays a gutter on the left-hand side, displaying the line number indicator. It also supports many common features, such as word wrap, auto indent, brace matching, undo redo, and adjustable zoom. When your cursor has the editor selected, you can use the control mouse wheel to zoom in or zoom out. You may have noticed that the window also supports syntax highlighting. Grun has a built-in heuristic syntax highlighter that it uses to color the tokens. For most languages, this is sufficient. However, users may supply an assembly containing a custom syntax guide. I will go more into detail about syntax guides in a later video. The editor window also supports drag and drop capability. You may drag text or files onto the window. If you drag a DLL file onto the window, it will attempt to load an ANTLR for grammar from the assembly. If there's more than one grammar within the assembly, you'll be prompted as to which you wish to load. If you drop any other file type onto the window, it will attempt to load the contents of the file into the editor as text. If you drop more than one assembly or more than one source file on the window at the same time, you'll get an error message. Now let's go ahead and load my Moo grammar and a source code sample by dragging them onto the window. Oh. Go ahead and use the larger one. There we go. You'll notice the assembly contained two grammars, which is why it prompted, so I selected Moo. While you may reload a grammar at any time by either dropping it onto the editor window or by using the menu, Grun will automatically reload any existing grammar if it detects changes to the source assembly that the grammar was loaded from. Likewise, if a custom syntax guide is loaded and it is changed, the editor will reload it in the background as well. This is designed to be as seamless as possible, thus allowing you to test a grammar as you recompile it without ever closing Grun or manually reloading the grammar. You'll notice that above the editor panel, there is a drop-down that contains the parser rules for the currently loaded grammar. The rules are sorted alphabetically to make it easy to find a specific parser rule. You may select a different parser rule at any time, and as soon as you change it, Grun will automatically reparse the source code using the specified rule and update all related data. Now, let's take a quick look at the menu bar. You'll see a standard file menu with options for loading grammar and source files. The options menu allows you to toggle syntax highlighting on or off, as well as toggle simple LL diagnostic and trace modes. And lastly, we have a help with the about. Now let's look at the various tab windows on the right. The first tab we have is Parse Tree. This tab has a tree view node guide and a graphical representation of the current parse tree. It should be noted that updates to the graph will be throttled based on the size of the source code and rate of change. You can find more about this in the configuration documentation. Both the tree view and the graph are interactive. If you select any node in the graph, it will select the corresponding source code in the editor window. Now let's go ahead and load a smaller sample file to make this a bit more manageable. You may select any node from the tree view guide, and the graph window will graph the subsection. So let's go ahead and break this down. We'll grab this if statement. You can see it selected the if statement in the source code, and it graphed only that subsection of the tree. Now, likewise, we can go ahead and click on the return statement. You can see it selected just the return statement in the source code. And now if I click the code section, it graphs the full graph or the full parse tree again. Alternatively, you can also use the graph from here menu option to graph a subsection. So we select that. You can see it immediately selected the tree view node guide that corresponded to that and graphed that subsection. as well as selecting the source text that corresponded. You can see right away that this graph is not terribly useful. So I'll go ahead and zoom in on the graph. You can use the trackbar to zoom in or the mouse wheel when you have the graph selected. Now I'm interested in this for loop. Now I'm going to go ahead and graph from here. Now right away we can see that this is a much more useful graph. You can see the graph viewer has a toolbar at the top with a number of functions. You can use these to zoom, move the graph around, or save the graph into various formats. Now let's move on to the Tokens tab. You can see this tab displays a list of all the tokens from the source text with various pieces of information about the token. Let's just go ahead and stretch that out a little bit. You can click on any token in this list to select the source code in the editor that corresponds to the token. Pretty straightforward. Now lastly, we have the Trace tab. By default, this is blank because we have tracing turned off. However, let's go to the menu and toggle on tracing. And now you can see it populated with the number of trace events. Now, this window displays all the trace events as the parser enters, exits, and consumes various parser rules. You may right-click on any trace event and get a context menu. So let's go ahead and we'll do this one. And from there, you can either select the token or select the parser rule. Doing so will select the corresponding section of the source code. So if we select the token, we can see it selected the return token there. And parser rule will select the return statement. Again, fairly straightforward. Now we'll move on to the parser error message window down below. Let's intentionally cause some parser errors in the source code. All right, so we'll just go ahead and put some garbage character in here. And immediately you can see we just got 4 different parser errors. If you click on any of these errors, you'll notice that it selects the corresponding source text associated with the parser error token. Now if we go ahead and fix our code, voila. Now the status bar at the bottom gives us various pieces of information. You can see the grammar that we have loaded currently, the current number of nodes in our parse tree, our current line number in the editor window, as well as our current column, and information about the throttling settings. The graph renderer automatically throttles based on the size of the source text, and this just gives you some basic information about the current state of the throttle. Now I'm going to go ahead and demonstrate the auto reload functionality using a simple lexer only math demo grammar that I created. Now let's go ahead and load the math grammar with a sample. So you can see right away I have a fairly simple math expression here. If we look at the tokens, well, you'll see the parentheses are not showing up. That's because in my grammar, I don't have any lexer rules for the parentheses. So let's go ahead and add those in. Now, we'll rebuild our solution, and voila, you see the parentheses just showed up. So, as you can see, it will just automatically reload everything like magic. Hope you found this walkthrough of the Grun.net project useful. All constructive feedback is welcome, and thank you for watching.